In this video, we're going to go over a few indefinite integral problems. And before we do, we need to differentiate between what an indefinite integral is and a definite integral is. So an indefinite integral is going to look like this, say of 5 dx, and a definite integral is going to look like something like this, 1 to 2 of 5 dx. And the difference between the two is an indefinite integral will have no numbers at the bottom and top of the integral function, and you're always going to have to add a plus c to the answer of your indefinite integral. Okay, so that should be sufficient. Let's get to the first problem. So what is the integral of 5 dx? Well, when you're integrating a constant, all you have to do is just add a variable to it. So 5x plus c is the answer to this problem. What about the integral of pi dz? Well, pi is a constant, so the answer to this is pi z plus c. Okay. What about the integral of 4 dy? Well, 4 is also a constant, so this is going to be 4y plus c. And let's do one more. The integral of e dx. E is also a constant, so we're just going to add a variable ex, and we can't forget the plus c. So the next type of problem you're going to see is a variable raised to a constant, and it's going to look like this. The integral of x to the n dx. And the way you solve this is you take x and to the n, you add 1 to the exponent, and then you divide by the exponent. Then you add c. So let's try our first problem. So let's try, for example, the integral of x squared dx. Well, if we add 1 to the exponent, that'd be x squared plus 1 divided by 2 plus 1 plus c. And if we simplify this, this would be equal to x cubed divided by 3 plus c. Okay. So take the integral of x to the 5th dx. Same thing, add 1 to 5, so that'd be x to the 6th, divide by 6, plus c. So how about if we had 4x to the 8th dx? Well, this is a little different. We actually have a constant that we have to deal with, and the way that we do this is we can actually rewrite this as 4 out in front of the integral of x to the 8th dx. And now we're just dealing with x to a power, which we've been doing in the last two problems. So we can just do that. So x to the 9th divided by 9 plus c, but we can't forget the constant. So we multiply this right here by the constant, and that would be equal to 4x to the 9th divided by 9 plus c. Okay, let's try another one. The integral of 25 x to the 10th dx. Well, we can rewrite it again like the last one. 25 times the integral of x to the 10 dx. So what we can do is we just add 1 to the exponent, so that'd be x to the 11th divided by the new exponent plus c, and we can't forget the 25, so we multiply this answer by 25, and we get 25 x to the 11th divided by 11 plus c. So try this one on your own. The integral of 5x dx. Okay, so the way you want to do this is, if you don't already know, x has an implied first power here. Okay, so if we just rewrote this as 5 times the integral of x to the 1st dx, well, this is just a simple this is just a simple problem now. We can just integrate x to the first, so we do x squared divided by 2 plus c, and then we multiply this answer by the constant 5. So this would be 5x squared divided by 2 plus c. Then here's another one, the integral of 10x dx. Same thing, we can rewrite it, 10 times the integral of x to the first dx. Well, this would be equal to x squared divided by 2 plus c, and then we multiply 10 by our answer. But we can also now simplify this. So 10 divided by 2 would be 5. So the simplified answer of this would be 5x squared plus c. So what if we had the integral of the polynomial function x cubed minus 5x squared plus 10 dx? Well, the way we do this is we integrate each one separately. So the integral of x cubed would be x to the 4th divided by 4 minus the integral of 5x squared would be 5x cubed divided by 3 plus 10x plus c. And that would be the answer to this one. Say we had the integral of pi x to the 6th plus 10x minus 7 dx. Well, we do it the same way. We integrate each one separately. Pi is a constant, so it just comes along for the ride. This would be equal to pi x to the 7th divided by 7 plus 10. So this is an implied first power. So this would be 10x squared divided by 2 minus 7. 7's a constant, so we just add an x. 7x plus c. We can also simplify this. 10 divided by 2 is 5, so it would be 5x squared. So we can have pi divided by 7, x to the 7th, plus 5x squared minus 7x plus c. Okay. So here's one that's going to be a little bit different. And it's just messing around with some algebraic stuff. Okay. So what about the integral of 1 over 5x squared plus 6x plus 25 dx? Well, the way we want to go about this is we want to rewrite this to where 5x squared, instead of being on the denominator, is now up on the numerator. So if we rewrote this as the integral of 5x to the negative 2, and the way we rewrite it is we just change the sign of the power. So this is x to the positive 2. To get it up to the top, we just switch it to a negative. So 5x to the negative 2 plus 6x plus 25. And then we can just, this is just another integral of a polynomial function, which we just integrate each one separately. Dx, okay. So if we added 1 to negative 2, that would be negative 1, then we divide by negative 1. So that would be 5x to the negative 1 divided by negative 1 plus 6x to the first plus 1 would be 6x squared. Then we divide by 2 plus 25 is a constant, so we just add an x. Then we add c. And if we wanted to simplify this, so 5x to the negative 1, to make it look better, we just switch the signs to get it back to the bottom. So we keep the negative, so negative 1 divided by 5x. We just switch the sign. Plus 6 divided by 2 is 3, so we'd have 3x squared. And then 25x does not need to be simplified. Plus c. And that is the answer to this problem. So say we had the integral of the square root of x dx. Now this is a little different because it's a square root function. We're taking the integral of a square root function, but essentially it's the same thing. All we're going to have to do is rewrite this so it's just x to the power of n. And the way we do this is this x has an implied first power, and the radicand has a implied 2. So we could rewrite this by saying the integral of x, and we do this by taking, so to the power of the radicand, which is right here, 1, divided by the index, 2. So x to the 1/2 is the same thing as the square root of x dx. And from here it's simple. We just add 1 to the numerator and divide by the new exponent. So adding 1 to 1/2 is the same thing as adding 2 over 2 because we have to get like terms, and 1/2 plus 2 over 2 is equal to 3/2. So this is going to be equal to x to the 3/2 divided by 3/2 plus c. But we're going to have to simplify this because we're dividing by a fraction and it just doesn't look well. We need to simplify it. So in order to simplify this, we multiply by the reciprocal, and the reciprocal is 2/3. So this is going to end up being 2x to the 3/2 divided by 3 plus c. And that's the answer, but multiplying this right here by the reciprocal turns into 2/3. Okay, so let's try another one like this. Say we have the integral of the 6th root of x to the 9th dx. We're going to go about it the same exact way. We are going to rewrite this as the integral of x to the 9 divided by 6 dx. And from here it's just the same thing. We add 1 to 9/6, which is the same thing as adding 6 over 6. So this is going to be equal to x to the 15 over 6 divided by 15 over 6 plus c. But we need to simplify it like last time. We're going to multiply by the reciprocal of 15 over 6, which is 6 over 15. So that's going to leave us with 6x to the 15 over 6 divided by 15. And then we can simplify 6 over 15 and the power of 15 over 6 by dividing by 3 over 3 here. So that's going to leave us with 2x to the 15 over 6 divided by 5. And then we can do the same thing to the exponent here, divide by 3 over 3. And that's going to be equal to 2x to the 5 over 2 divided by 5 plus c. And that's going to be the answer. But we can even, so we can leave it like this and that's totally fine. But we can rewrite x to the 5th as a root, and we can do it just like this. So 2/5 times the square root of x to the 5th plus c. And the way we did this is we just did the reverse of writing the radical as a exponent like we did up here. We just took the 2 and put it here because the square root has an implied second power, and then we just raised the inside function right here to the 5th power. And that's how we did that. So this is the answer to the integral of the 6th root of x to the 9th. Consider this, the integral of the fraction pi x squared plus 6x all divided by x dx. So the way we go about doing this, we want to make this look as simple as possible. So we're going to break this up into 2 separate fractions. It's going to be the integral of pi x squared divided by x plus 6x divided by x dx. And now we can just do this by parts, just like we did with the polynomials. But first we're going to have to cancel out these x's. So this is x to the 1st and x to the 1st. When we simplify this, it's going to be the integral of pi x, because x to the 1st minus x squared is x to the first, and then x to the first minus x to the first is x to the 0, which is 1, so 6 times 1 is 6. So this is going to be pi to the x plus 6 dx. From here, we just do each one separately. So pi is a constant, so it's just going to be pi x squared divided by 2 plus 6 is a constant, so we just add a variable, plus c. And that is it for this one. That is the answer to the integral of pi x squared plus 6x divided by x. Okay, so here's another one. What if I gave you the integral of 1 divided by x to the 4th dx? Well, we want to get x to the 4th to the numerator, so we're going to rewrite it, and we're going to say the integral of x to the negative 4th dx. And from here, we can just add 1 to the exponent and divide by that. So this is going to be x to the negative 3 divided by negative 3 plus c. And from here, to simplify this, so this negative goes out to the front, so it's going to be negative, and we're going to switch the signs on this to a positive, so x to the negative 3 is going to be x to the third on the bottom, so it's going to be negative 1 divided by 3x to the third plus c. So for the next fraction, we're going to say the integral of e divided by x cubed dx. Just like the other problems, we're going to want to make this into something that's not a fraction, so we're going to switch the signs from a positive to a negative and bring this up to the top. So we're going to rewrite this as the integral of e times x to the negative third power dx. E is a constant, so we're going to bring it out to the front. We're going to say e times the integral of x to the negative third dx. And then we're just going to go about this like any other x to the n problem. We're going to add 1 to the exponent and divide by that. So negative 3 plus 1 is negative 2. So we're going to say x to the negative 2 divided by negative 2. And we can't forget the constant e, so we're going to multiply e by this answer right here. So this is going to be ex to the negative 2 divided by negative 2 plus c. But to simplify this, we're going to take this negative out to the front, so it's going to be negative, and we're going to switch this sign to a positive, so we're going to bring the x to the negative 2 to the bottom, and it's going to be negative e divided by 2x squared plus c. And that is the answer to this problem. So consider this fraction. Consider the integral of 1 divided by x dx. If we go about this the same way and we switch the signs from a positive 1 to a negative 1, we're going to get the integral of x to the negative 1 dx. And if we add 1 to the exponent and divide by the exponent, say we do x to the 0 divided by 0 plus c. If you didn't already know, dividing by 0 is a big no-no. You can't do that. So we cannot go about solving this problem this way. So for right now, just know that the integral of 1 over x dx is the natural logarithm of x plus c. If we were to do another one similar to this, say we had the integral of 1 over x minus 4 dx, just like the above, the antiderivative of this function, or the integral of this function, is the natural logarithm of x minus 4 plus c. So we're going to do one more integral just like the last two. So if we take the integral of 5 divided by x minus 2 dx, as you can see, the bottom is power of 1, so we get the same problem, division by 0. As you can see up here, the integral of 5 over x minus 2 dx is the same as the integral of 5 times 1 divided by x minus 2 dx. And since 5 is a constant, we can just pull it out to the front. So if we wrote 5 times the integral of 1 over x minus 2 dx, you can see that the integral of this inside function right here is the natural logarithm of x minus 2 plus c, and we can't forget the constant 5. So we multiply 5 by this answer, and we get 5 natural logarithm of x minus 2 plus c, and that is the answer to this problem. So now we're going to get into integrating trig functions. So we're going to go over the basics first. We're going to go over the integral of the basic trig function cosine of x dx. Well, if you think backwards, the derivative of what function is cosine? Well, the derivative of sine is cosine. So the derivative, or the antiderivative of cosine, must be sine. So the antiderivative of cosine x dx would be sine of x plus c. Consider the next trig integral of sine of x dx. So the derivative of cosine is negative sine. So the derivative of negative cosine is sine, which means the antiderivative of sine is negative cosine. So negative cosine of x plus c. Let's get into one where let's get into this one. Consider the antiderivative of cosine of 3x dx. Let's put those brackets there. So we know the antiderivative of cosine, which we did up here, is sine of x. So the way we do this is we just take the antiderivative of this and keep the angle the same. So this is going to be sine of 3x, but then we divide by the derivative of the angle. So the derivative of 3x is 3. So we're going to divide by the derivative of the angle, which is 3, plus c. And that is going to be the answer to this problem. So try this integral yourself. Can try the integral of cosine of 7x dx. Well, we're going to do it just like we did on the previous trig functions. The antiderivative of cosine is sine, and then we keep the angle, so it's going to be sine of 7x. Then we divide by the derivative of the angle, and the derivative of 7x is 7, so we divide by 7 plus c. Okay, we'll try another one. The integral of 14 sine of 2x dx. So this constant, we can bring it out to the front, and we can say this is equal to 14 times the integral of sine of 2x dx. And we know that the antiderivative of sine is negative cosine, so we can say that this is negative cosine, we keep the angle the same, of 2x divided by the derivative of the angle, and the derivative of 2x is 2, divided by 2 plus c. Can't forget the constant, so we multiply this answer by 14, and we get 14 times this. And simplified, this would be negative 14 cosine of 2x divided by 2 plus c. And we can further simplify this because 14 divided by 2 is 7, so we could rewrite this as negative 7 cosine of 2x plus c. Let's try this one. The integral of 6 sine of 3x dx. Okay, so we can bring out this constant to the front. So this would be equal to 6 times the integral of sine of 3x dx. And we know that the integral of sine is negative cosine. So we will say that negative cosine, we keep the angle the same, of 3x divided by the derivative of the angle, which the derivative of 3x is 3. So divide by 3 plus c. And then we can't forget the constant. So we're going to multiply 6 by this. And we are going to get negative 6 cosine of 3x divided by 3 plus c. And this can be further simplified. Negative 6 divided by 3 is negative 2. So this is going to be equal to negative 2 cosine of 3x plus c. So let's try this integral. The integral of secant squared x dx. Well, at first you may not know how to solve this, but if we think backwards again, like on the other problems, the derivative of tangent is secant squared. So the antiderivative of secant squared must be tangent. So the answer to this actually is just tangent x plus c. Let's try 8 secant squared of 4x dx. So first we're going to want to move this to the front, so we're going to say this is equal to 8 times the integral of secant squared 4x dx. We know that the antiderivative of secant squared is tangent x, so we're going to say tangent of 4x, because we're going to keep the angle the same, divide by the derivative of the angle, which is 4. So tangent of 4x divided by 4 plus c. And we can't forget the constant 8, so we're going to multiply this by 8. So this is going to be 8 tangent of 4x divided by 4 plus c. But we can also simplify this, because 8 divided by 4 is 2. So in simplest terms, this is going to be 2 tangent 4x plus c. Okay, here's another one. Consider the integral of secant x tangent x dx. Okay, so if you know the derivative of secant, it's secant tangent. So the antiderivative of secant tangent is secant x. So the answer to this integral is secant x plus c.